Geometry Module 3, Topic 1, Lesson 2. We're in Activity 2, and specifically page 464. We're talking about another triangle similarity criterion, and it's side, side, side. So if you haven't seen this one, this is the poster notes video from our other section. You are encouraged to go back and watch that one as well. Take some notes on it and then make it make meaning for you. This activity is going to go into the deeper concept of how do we know whether or not two triangles are similar because of side, side, side. It's not, by the way, that the sides are going to be equal. It's that the sides are going to create proportions. The proportions will be equal. The diagram here shows PQ as a line segment and a center of dilation C. The rays in the dilation, so arrows, form a triangle CPQ. Tabby says that any line segment drawn from CP, that's the ray, to CQ will produce a dilation of PQ. So a dilation ray is a shrink or a stretch, some sort of like expansion or contraction of a line or a shape. And we're going to talk about how this line segment will be expanded or contracted if we draw, Tabby says, if we draw a line segment across the arrows. Which would mean then that the new triangle, CP prime Q prime, would be similar to the original triangle, which is right here, CPQ. Ellen disagrees, and she says that the line segment drawn must be parallel, and that is 100% necessary. We must establish that the line drawn here is parallel for the triangles to be similar. Who's correct? Well, let's do that. In fact, I'm going to say it's Ellen. Maybe I gave the answer way too soon, sorry. I'm going to say Ellen is correct because if I use what she said and I line up my protractor straight edge, it's kind of a Cheez-It way to do it, and then I draw a line segment across from one arrow to the other, I'm creating P prime and Q prime. So this bigger triangle is made up of three angles, and because of the way I constructed the parallel lines, angle P prime is the same as angle P. You have to have angles that are the same size, measurement, in order for the triangles to be similar. And if I look at angle Q, double arc there, and angle Q prime, double arc there, those are two angles that are the same, and therefore by the angle-angle similarity criterion, small triangle CPQ is similar to big triangle C prime Q prime. So Ellen uses corresponding angles in parallel lines to show angle P is congruent to angle P prime and angle Q is congruent to angle Q prime. And because of that fact, that means triangle CPQ is similar to triangle C prime Q prime by angle-angle similarity. All of that is necessary in the conversation about whether or not we're going to show the two triangles are similar. Let's do number 2. Construct triangle D prime E prime F prime by doubling the lengths of the sides. In order to do that, I'm going to use some tracing paper here. So some tracing paper is going to let me, first of all, trace triangle DEF. Now they want us to construct the new side lengths separately. I'm not really going to do that. The key thing is that's showing how we could use a compass in order to capture the distance of the sides and then use the compass overlap to find where the shapes line up. Just do this with the tracing paper for now, and this will be sufficient. DE and then F, trace it. Maybe you have your tracing paper from the previous time we looked at this exact triangle. Now, if I flip this over and trace on the other side of it, I'm going to push graphite. That's the trick with the tracing paper. Get graphite to be on both sides of the tracing paper. So I've traced both sides now. Okay, here we go. In order to double the length of the segment, well, first of all, I'm going to sketch these two segments, but not the third. That's the thing. I'm not going to do the third. There it is. And then I'm going to take my tracing paper. I'm going to slide it perpendicularly so that my triangle is now a full 2 sections longer than where it was before. I just didn't go far enough. There. Okay? And bring in the protractor and a pen or something and make that line be a nice, lovely straight line. So here goes. Okay. D prime, E prime. And it's twice as big because of that, double up technique. In fact, if I do that with the location of F, slide the tracing paper. You got to be careful not to twist it. Twisting the tracing paper will be bad, but we're going to slide it, and then we're going to make a mark all the way down to there. This is where F will be located, and I use my protractor to draw a nice, lovely straight line. So edge, good, F. Last, with an apostrophe, F prime. So last of all, this should work for us to trace the third side by doubling EF. Double, and of course it is, right there. It fits 2 of these triangles, well, 2 side links, right? Doubling the side links will make this full triangle fit inside the other. Get it lined up, get it lined up. There we go, a little lineage, there we go. So here we go. We have constructed the triangle. We've not duplicated any angles. Angle D and angle D prime are the same. Angle E and angle E prime are the same. Angle F and angle F prime are the same, but the side lengths are now twice as big. So whatever this DE was, D prime E prime is double that amount. Whatever the length of that DF side is, D prime F prime will be double the length. And then last of all, that third side, EF, the other triangles E prime F prime will be double the length of it. That's it for page 464. Maybe a question to consider is, why do you think all pairs of corresponding angles are congruent? And it does go back to what we talked about with parallel lines being used. Parallel lines preserve equal angle measures. That is our last of the video. Thanks for watching. I'll see you in the next episode. 465 is next.